Hello everyone. In today's session, I'm going to discuss the concept of stable matching problem, which is widely used in various domains, where, especially in the situation where we are having two group of individuals and they are having their preferences, and on the basis of their preferences, we are trying to find a optimal matching on both the sides, job and professional allotment. A group of professionals are there, a group of jobs are there. We do have their preferences, and on the basis of their preference, we are trying to find the optimal matching between them. It can be used in the college admission, like we are having group of students with the preference and group of university with their criteria. We can find these in resource allocation, jobs allocation. Means wherever we are having two group of individual and we want to find the matching between them as per their preferences, as per their expertise, we can use the concept of the stable matching problem, or we can call it as stable marriage problem also. In few of the books, we can say. Okay, so there are certain rules that we are having for this concept. So we are supposed to follow the rules, and after the rules, we will say a problem is stable if we get a optimal matching. What we mean by optimal matching, when we are talking about two group of individuals, first we will try to find the matching from by assuming first as proposing group and second is accepting or rejecting group. Then we'll reverse the role. The proposing group becomes the accepting or rejecting group, and the rejecting or accepting group becomes the proposing group. We'll get one more matching in that case. If from both the side we are getting the same matching, we'll say the problem is a stable problem and it is having a stable solution. And whatever matching we get on both the side, we call this as the solution of the given problem or optimal matching for the given problem. Okay, there are certain steps, or better to say, the algorithm is having certain rules. We are supposed to follow these rules to try to find the optimal matching. Okay, so let us start. Let me share the screen. First, I will discuss the rules and then we'll take few of the examples on it so that you can easily understand the concept. So let me share the screen. Okay, so let us see. As I already discussed, it is one of the type of classical problems where we are supposed to find the optimal matching between two individuals. It has application as already discussed. Various applications are there for these things, especially when we are having preferences of two groups. And as for the preference, we are supposed to find. These are few of the applications that I already discussed. Matching resident to hostels or patient to hospital, college admissions, employment to employee to job allotment, partner matching problem, and others, many more. Okay. So these are the few applications with what exactly a matching problem is. So this is what the algorithm that we are having. These are the steps that we are supposed to follow when we are going to find the optimal matching for a problem. So the first step is what it will be applicable in the case when there are two groups of individual. One group we call as a proposing group and another we call as a accepting or rejecting group. One individual from the proposing group who is not already engaged will propose to their most preferable option who has not already rejected him. So, as per the given preferences, the individual will start to exercise their preferences. Like if there's an individual whose first preference is X, he or she will propose to X, and that X will accept or reject as per the following conditions. The proposal will be accepted by X if this is the first option or offer he received. This offer will be rejected if it is the worst choice, if it is the worst choice compared to the current choice he or she is having. The third one is what? It will be accepted if it is better than the correct option. So overall, it means what? We will start from proposing group to accepting to rejecting group. Proposing group will exercise their first choice first. The first choice goes to that individual, and if that individual is not engaged anywhere till now, the proposal has to be accepted. If he already engaged, he already engaged somewhere, but the option is better than the correct, he or she have to accept that option. The option or offer get rejected if this option is not better than the correct one. We will proceed in the same manner for each individual, like individual one exercise first option, then individual two exercise their option, then three, then four. And we will do continuously until unless we will get a matching. Once a matching is obtained, then we will stop this process and reverse the rule. Reverse the rule means what? The one which is earlier, the one which is earlier proposing group will become accepting and rejecting group, and the one which is accepting or rejecting group will become proposing group. Okay, so these are the points that we are having. If we get perfect match from both the side, we will say the given problem is stable. Now, talking about the solution, we will say the problem is stable if we are getting same matching from both the side. The matchings are different. We call the problem is unstable. There is no optimal matching possible on the basis of the given preferences. Okay. Now, we may choose any group as proposing or accepting group, but the role reversal is also there. If first group is proposing in the first term, then in second term, first group will become accepting or rejecting group. Because we are finding matching on both side of the preferences. It's not from the one side of preferences. In the same manner, like if we consider man and woman group. If first round we consider man as a proposing group, then women's are accepting or rejecting. Then in round two, we consider women as proposing or accepting a proposing group, and then man will become accepting or rejecting group. Okay. If both the side give the same matching, we call the problem is stable. So these are few of the steps that we are having. Okay, now let us take one example on it. We should take care about these rules. The options or whatever preferences are given on that basis, we are supposed to exercise option one, option two, and the others, and accepting and rejecting, as already discussed. If it is the first offer, he or she is getting, he have to accept it or she have to accept it. If it is better than the current, it must be accepted. It will be rejected in the third case if it is worse than the current scenario. Okay. Now let us take one example on it. So it is given in a survey of four boys, A, B, C, D, and four girls. The following preferences are obtained. Now we are supposed to find the optimal matching between boys and girls on the basis of these preferences. Okay. So the first table gives the preferences from boys to girls. Capital A, B, C, D are the representation for the boys, and small a, B, C, D are the representation for the girls. So, as we are supposed to check the stability for the problem, we are supposed to check it in the both way. Okay, so suppose in the first round, I am taking boy as a proposing group and girls as a accepting or rejecting group. So let us see the first step. The first step, so let we can consider this as step number one. Step number one is what? Boy A. The first preference for boy A is option C. So A proposed to C, and if we comes to C, till now you can say there is no offer available with C. So A is the first one who give the proposal to C. So this proposal is accepted. I am using a circle notation for a proposal to be accepted, and I will cross it if it is not accepted. Okay. Now moving to boy B, the first preference of boy B is a small b. A small b also not engaged anywhere till now, so this proposal have to be accepted. The proposal is accepted by B. Moving to C, C proposed to small c. And now you can see when option offer comes from capital C to small c, but C is already engaged somewhere. But you can see currently C is engaged with A, but now option comes from C, which is the first choice for him. So this will accept, and this the present offer is worse than the offer that she get is better than the current one. So the current get rejected and this will be accepted. This is the important point over here. When C proposed to C, then small c accepted because it is better than the current offer or current option she is having. So this got cancelled. It means the first option that I gave A to C also get cancelled. It is important to cross these two. Otherwise, you will get many confusing statements over here. Like in this table, A to C is connected, but here C to A is cross. So cross in both the tables. Now moving to capital D propose small c, but you can see here C is already having the best option. So this proposal will not be accepted, or I can say rejected. So D proposed to C but not accepted. So this is what the first round is completed, where you can see A not get the first option, B get the first option, C get the first option, also D not get the first option. Okay, now let us start the round number two. In round number two, the second option for A is B. So A exercise its second option. A proposed to B. Over here, if I see B is already engaged with B, but better options comes. So this proposal will accepted and this B get crossed. This B get crossed, so the proposal which is there B to B get also crossed. Understood? Now moving to the second step, now B moved to A. B proposed to A, and till now there's no proposal received to this A. B proposed to A and no proposal is there with A, so this will be accepted. So A accept the proposal which comes from B. Now moving to third, C already settled down. So the one which is settled, we are not supposed to disturb. Moving to D, now D, the second option of D is A. So D exercise the second option of A. But if you see the A is already having the second choice and D is the third choice. So this option will not be accepted, or better to the proposal is rejected. So the second proposal of D is also rejected. So this is about the round number two, which is completed. In round number two, A is settled down, B is settled down, C is settled down, but D is still single. So now in the third round, we will only start with D because first three is already settled. Now D exercise the third option, which is D. So D proposed to small d, and small d also not having any proposal till now. So this proposal D had to accept. So this is the round number three. And after round number three, in the first one, which is proposing group, all of them are settled. We are supposed to check the proposing group is settled or not. Okay. So what I get after this step, A is settled with B, and B is settled with A, C is settled with C, and D is settled with D. We are having four boys with four girls, and this is what we get the matching from in the first step, where boys is proposing group and girls is accepting or rejecting group. Okay, so this is what the first preference we have obtained. Now, can I say the problem is stable? The answer is no. Why? Because in order to say the problem is stable or the problem is having optimal solution, we are supposed to check matching on both the end. In step one, we have checked the matching from boys to girls. Now we will reverse the role. That means now girls will be the proposing group and boys will be accepting or rejecting group. So let us see the step number two. So now I will first draw the table of girls to boys and then boys to girls, because now our girls section is proposing group and boys section is accepting or rejecting group. So in the same manner, now A will exercise the option A, small a, propose capital A single. So the option or offer is accepted. Now small b proposed to capital C single, so offer is accepted. Small c proposed to capital C, but capital C already engaged. But as a rule, the point second or third says that if the option comes which is better than the current, it will be accepted. So C will accept this proposal and cross the earlier project. C already engaged with B, but then what happened? Boy C get the better option. So this B to C also get cancelled. Do remember we are supposed to cross from both the table. Moving to D, the first option for D is B. B didn't get any offer till now, so the offer have to be accepted by B. So this is about the first round. A is settled with A, C is settled with C, D is settled with D. But still B is not settled anywhere. So we will start the choice number two for everyone. Now, should I consider the choice number of A? Should I consider the second choice of A? The answer is no, because already the girl A get the first preference. Now talking for B, the first preference is cancelled, or we can say not accepted. So B will exercise the option number two, which is A. Now on A, you can say A is already engaged with A, but better option comes. So better option comes means what? This option is accepted by A. Then what will happen? The current offer will be declined, or we can say crossed. So A to A also got crossed. C to C already settled, will not disturb it. B to B is already settled, will not disturb it. So now after second round, B, C, D is settled, but A is still not settled. So now A will exercise the second option, which is A to B. It goes to B. So B get the better option than current, so accepted. So B to D get cancelled out. So B to D get cancelled out. That means D to B get cancelled out in the first table. So now C is settled down. D will exercise the option number two, which is A, but it will also get rejected because A is already having better than D. Now, D will exercise the option number C. So D will exercise the option number C, which get rejected from here because C already having the best option. Now D will exercise the last option, which is D, and D is still single. So this have to accept it. Now suppose that the last option also get crossed or not accepted. So in that case, D will never settle down with everyone, and without any doubt will say the problem is not stable. No optimal matching is possible as per the given preferences. Okay, now let us check once again. We can say A settled with B, B settled with A, C is settled with C, and D is settled with D. So all the individual of proposing group are settled. So we'll stop the procedure and see what the matching we get. A is settled with B, B is settled with A, C is settled with C, and D is settled with D. This is the round two, or we can say step number two for checking optimality. Now, both the step is completed. We are supposed to write the concluding remark whether the given problem is stable or not. So for this, we are supposed to check if from both the side we are getting the same matching. From both the side we are getting the same matching. We'll say the given problem is a stable problem. So let us check it. It is A to B, B to A, C to C, and D to D. And in step A, 1, A to B, B to A, C to C, D to D. That means from both the side we get the same matching. So the concluding remark is what? Since step number one and step number two give the same matching, hence the given problem is stable. Is stable means that is it is having it is having a stable matching, or we can say a optimal matching. And what is that matching? That solution is A is supposed to set with B, and B is supposed to set with A, C is supposed to set with C, and D is supposed to set with D. This is what the solution of this problem is there. Understood. So I hope you understand the concept. Very simple, but on the same time, we are supposed to use your logical skills when we are assigning someone to someone as per the given preference. There are 3 to 4 steps that you are supposed to use. Now, let us take one more example. Remember one thing, it's not like everyone is having the same number of preferences. Like in this table, you can say M1 is having 4 preferences, M2 is having 3 preferences, M3 is having 2 preferences. In the same manner, W1 is having 3 preferences. So the number of preferences may vary. It's not always a square matrix. Everyone have to give the preference to everyone. No, it's not necessary. It may possible that an individual gives only 1 preference or only 2 preference or 3 preference. So it may possible. So let us try to find the stability for this problem. Over here, we are also supposed to do the same thing. Here some M1, M2, M3 is given, and their preferences for W1, W2, W3, and W4 is given. So let us try to solve it. The first preference of M1 is W2. So M1 proposes to W2 and W2 accept this proposal because this is the first proposal W2 received. Now M2, the first option is W3 and W3 accept the proposal because the first offer W3 get. M3, the first preference is W2 and W2 is already engaged with M1. But the thing is that M3 is better than M1. So the proposal is accepted and this is got crossed. So W2 to M1, that is M1 to W2 get crossed in both the table. Now M4 proposed to W4 and W4 accept this proposal. So this is how the round number 1 is completed, where M2, M3, M4 get their first choice, but M1 not. So now it's time to exercise the second option for M1. So now the second option of M1 is W4. So M1 approaches to W4. Yes, W4 will accept it because it's better than the current choice. M4 to W4 get crossed now. We will not disturb M2, M3 because already settled. But M4 will exercise the option number 2, which is W1. So yes, it will be accepted because till now W1 didn't get any proposal. So if you see the proposing table, this is the table. So what I get, M1 is settled with W4, M2 is settled with W3, and M3 is settled with W2, and the last one is M4 settled with W1. This is what we get the matching when your M1, M2, M3, M4 is proposing group and W1, W2, W3, W4 is our accepting or rejecting group. Now we will perform the same by reversing their role. Now W1, W2, W3, W4 will become proposing and M1, M2, M3, M4 will become accepting or rejecting group. So now, step number 2, I interchange the positions. So now W1 proposed to M2, M2, W1 accepted. First option, or you can say first offer received, W2 proposed to M4, M4 will accept W2. W3 approaches to M1, M1 will accept this W3. W4 propose M2 and M2, it will not be accepted because you can see W4 is worse than the correct option. So rejecting. Now W4 exercise the second option, which is M1. So W4 to M1, yes, it will be ex accepted because better than W3, this cross. M1 W3, W3 M1 got crossed. So now first, second, and fourth is settled, but still W3 is not settled. So W3 now exercise the second option, which is M4. So M4 accept W3 because it is better than the current option M4 is having. So this is crossed. So W2 M4 got crossed. Now W2 will exercise the third option, which is M3. M3, W2 approaches to M3 and M3 accepted because it is the first option or first offer M3 get. So now you can see in the first table, everyone is settled down. Let us see what the preference we get. W1 is settled with M2. W2 is settled with M3. W3 is settled with M4. And W4 is settled with M1. So we find matching from both the sides. Now we'll say the problem is stable or not after comparing the matching on both sides. So you can see over here W1 is with M2. If I see over here W1 M2, here M2 is with W3. You can see this matching is not same. W2 is with M3 and M3 with W3. This is what the correct matching. W3 is with M4 and M4 is with W1, so not correct. W4 is with M1 and M1 is with W4. So now overall you can say all the matchings are not same. So the problem is not stable. Not stable means what? As per the given preference, no optimal solution is possible. No optimal solution is possible. Okay, but still you can see M1W4 and M3W2 is same in both the cases. So we can say these two matching are optimal, but individually they are optimal, but overall scenario for this problem is not optimal. As the given problem is not stable, or we can say no optimal solution exists for it. I hope you understand the procedure. This is one more example. You can try it by yourself. Okay, so this is all about for this session. Let us close this session now.